Welcome to Module 1, Lesson 14, from ratio tables, equations, and double number line diagrams to plots on the coordinate plane. Alright, so after today's lessons, I would hope you'll be able to associate an ordered pair with each ratio. So take a ratio and turn it into an ordered pair and vice versa. Plot the ordered pair in the XY coordinate plane. Represent ratios in tables, equations, and double number line diagrams. And then also represent those ratios in the coordinate plane. Right, so basically at the end we want to be able to take all four of these, and if I have a table, make an equation, a double number line, and a coordinate plane. And all kinds of combinations there. So whatever I give you, I want you to be able to create the other things from it. Alright, so we're going to start with Kelly and her soccer team that's traveling from Yonkers, New York to Morgantown, West Virginia for a soccer tournament. The distance between Yonkers and Morgantown is 400 miles, and the total trip will take 8 hours. So below we have a train schedule provided that tells us when we leave Yonkers, they're going to stop in Allentown, which is 100 miles away, Carlisle, which is 200 miles away, Berkeley Springs, which is 300 miles away, and then Morgantown, which is 400 miles away. Then on the way back, they do everything in reverse. So from Morgantown to Berkeley, 100. To Carlisle, it's 200 miles. To Allentown, it's 300. And to Yonkers, it's 400. Now, that doesn't mean between Allentown and Yonkers, it's 400. No, it's from Morgantown to this place. So from Morgantown to Beverly Springs, it's 100 miles. From Morgantown to Allentown, it's 300 miles. Okay, so we're going to take this information and create a table to show the time it will take Kelly and her team to travel from Yonkers to each town in the schedule, assuming that the ratio of the amount of time traveled to the distance traveled is the same for each city. So this is a key piece right here, knowing to assume that the ratio of the amount of time traveled to the distance traveled is the same for each city. So that means that their speed was the same the entire time. Okay? In order to complete this problem, we have to assume that it travels at a constant speed. After that, we're going to extend the table to include the cumulative time it will take to reach each destination on the ride home. Right, so basically what we're doing is we are creating the table for the ride there and for the ride back. So to start off, I am going to write down that I know my number of miles is 100 because I'm going to Allentown, and then it's 200 miles, and then it's 300, and then it's 400. Now, for this table, what we're doing is we're talking round trip. So we're talking total number of miles. So when they go 400 miles, they arrive at Morgantown, West Virginia. Then when they go home, they're going to go another 100 miles, so that'll be 500 total miles. And then another 200 miles, so that will be 600 total miles, so on and so forth. So in this case, it worked out perfectly where we matched up the miles to our table. But then here we added to our table by saying, okay, we're going backwards. So now we went 400 miles. To go back to Berkeley Springs, we had to travel another 100 miles. So we're at 400 miles on the way there, and then 100 miles to get to Berkeley, which gave us that 500 miles total, so on and so forth. Now, to fill this out, we have to think of the information that we know. If you go back to the first problem, it tells you that it will take 8 hours to travel the 400 miles. So we can put that in here that it will take 8 hours to travel the 400 miles. Now, since we're assuming that the speed is constant the entire time, I can use this ratio to help me create the other ratios for my time to miles. All right, so I have to look at how did I go from hours to miles, right? I know that 400 is 50 times as much as 8. So I know that in order to go from miles to hours, I have to multiply by 1/50th. Because remember, we talk about doing the reverse. So since 8 times 50 gives me the 400, I know that if I take this and I flip it, so I can say take the reciprocal, then I can take my miles, because I know all of my miles, and get my hours. So if I take 300, that's my number of miles, multiply it by 1/50th, I will get my number of hours. Well, when I do that, I get, so 300 times 1 is 300. 1 times 50 is 50. And then I can reduce, so both of these can reduce by 10. I get 30 over 5, which is equal to 6. So I know it will take me 6 hours. Now the other thing that I know is that once I find my additive structure, I can use it to fill out the rest of my table. So I know that when I added 100 miles, I added 2 hours. Notice we're using all kinds of different ways to fill out our table here because we've learned so many different ways. So now I know that in order to go from 6 to my previous number, since I would have added 2 to go from this number to 6, I know that I have to subtract 2 to go backwards. So I would do 6 minus 2 gives me 4. And then I can do the same thing here. I know I'm writing down plus 2, but I'm showing you the additive structure. Since we're going backwards, we do the opposite of addition, which is subtraction. 4 minus 2 is 2. Okay, and then now we can go ahead and fill out the rest of the table because we know that for every 100 miles we add 2 hours. And then I can double check this by making sure that my hours times 50 equals my miles. All right, so I know in total the entire trip should take me 16 hours. So now we're going to take this one step further. Now we are going to create a double number line diagram to show the time it will take Kelly and her team to travel from Yonkers and to each town in the schedule, and then extend the table to include the cumulative time it will take to reach each destination on the ride home. So on top, I'm going to put my hours, and down here I will put my miles. I start at 0 on both, and then I know that from my table, in 2 hours I will go 100 miles. In 4 hours I will go 200 miles. In 6 hours I will go 300 miles. And notice my lines aren't entirely perfect, but I do have somewhat the same amount of space in between each. And in 10 hours, I will go 500 miles. In 12 hours, I will go 600 miles. In 14 hours, I will go 700 miles. And in 16 hours, I will go 800 miles. Okay, so we've created our double number line, and now we want to look at the relationship here. So I know that in 2 hours, I will drive, or the train will go 100 miles. Or if the train goes 200 miles, it will take it 4 hours. So we need to be able to put this information together in order to use it for our next problem. So I'm going to go ahead and I'm going to move this up, and I'm going to copy and paste here. So that way I have enough space for the next part of the problem. All right, so what I'm looking at here is the double number line and answering some questions and then creating that equation that the first part talked about. So if I use the information from the double number line diagram, how many miles would be traveled in 1 hour? I want you to take a second and pause and figure out your answer. Okay, I found that in 1 hour it would go 50 miles. So 50 miles traveled in 1 hour. So now it wants to know, well, how do I know? Well, since I'm going backwards from 100 to 50, I have to think of 50. How far between 0 and 100 is that? Well, since I know 50 is halfway between 0 and 100, then the amount of time has to be halfway between 2 and 0. Okay, because 0 miles takes us 0 hours, and 100 miles takes us 2 hours. So since we're going only half the distance, it should only take us half the time. Okay, so make sure you write out your full explanation. So since 50 miles is halfway between 0 and 100, I know my time had to be halfway between 1 and 2. Again, if you need more time, don't hesitate to pause and get this written down. And don't forget our label of hours. Now, the key part here is that since the assumption is that the speed was constant, this works. So now we want to put together an equation. We want to know, how do the time and the miles work together? So if I look here, I know that for every 50 miles that I travel, it takes me 1 hour. So I know that the value of this is 50 over 1. Since I did miles to hours, I know that to use this value, I would have to be going from hours to miles. So I know that if I take my number of hours and multiply it by the value of my miles to hours, so if I take my hours and multiply it by 50, it should give me my miles. Or I can look at it and go from miles to hours. Since I'm going from miles to hours, I want to set up my ratio for hours to miles. Remember, we're working backwards. And that is for every 1 hour, I go 50 miles. And mind you, we're using this ratio because it has the 1 in it, and it makes it a lot easier than having to simplify. I know the value here is 1/50th. So I know that if I take my number of miles, multiply it by 1 over 50, I will get my number of hours. So basically what it's saying is if I take my miles and split it up into groups of 50, that 1/50th will be my number of hours. So for example, if I take my 200 miles and split it up into groups of 50, so 50, 50, so 50, 100, 150, 200. Since there are 4 of them, I know that it will take me 4 hours to go 20 miles. Okay, so now that we've done that, all those things that we just did, we've done in the past. So we should be fairly good at them at this point. Now we're going to take that and extend it to the coordinate plane. For right now, we're working with a coordinate plane that only has positive values. Okay, so up and to the right are all positive values. And we're going to fill out our table here without the ordered pairs. So for right now, I know my hours were 2, 4, 6, 8, and 10. And I know that my miles were 100, 200, 300, 400, 500. So now I need to look at how I want to set up my coordinate grid. Okay, and I'm going to give us a little bit more space here, so I'm covering up the question a little bit. Okay, and the question asks us, if dinner service starts once the train is 250 miles away from Yonkers, what is the minimum time the players will have to wait before they can have their meal? So once it's 250 miles away from Yonkers, and I want to know what is the minimum time they have to wait. So I would say, to make sure I'm answering correctly, I would write my sentence and leave a part blank for my answer. So my answer would look something like this. They would have to wait. And since we're talking about waiting, we're talking about time, so we would say blank. And I know we're talking in hours, so it would be blank hours. All right, so now we're going to talk about how to set up your coordinate plane. When you set up a coordinate plane, you need to make sure that you're putting your independent variable as your x and your dependent variable as your y. So most of the time, your independent variable is your time because time just goes and goes and goes. Okay, time doesn't really depend on anything. So your time in this case is going to be your x. And you know that your distance depends on how long you were driving. So that's your dependent variables. So your distance depends on your time. Okay, and actually I'm getting a little crunched for space here. So I'm going to actually make this a little bit smaller. We should be okay. There we go. Now we also need to think of how we want to put our numbers on our axes. You don't want to make your intervals too big and you don't want to make them too small. If you make them too small, your graph is going to be too crunched. If you make them too big, you're not going to have enough space. So here, time goes up by 2, and we're only going up to 10 in this case. So since we're only going to 10, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Since we have 21 lines, we can go up. Okay, we can go up a little bit bigger. So we can say that this here is 1 hour. And when you do time, you also have to write down what your label is. In this case, we're talking about hours. Okay, so we have 1 hour, skip a line, 2 hours, skip a line, 3 hours, skip a line, 4. Okay, at this point you should get it, so go ahead and continue to fill out the bottom part of your coordinate plane. If you want to pause to make sure that you have it correct, that is absolutely okay. Okay, but now you should have, make sure you have one line in between your number and your next number. So 1, skip a line 2, skip a line 3, skip a line 4. Now with our distance, we're going up to 500 miles. So counting by ones isn't really going to work. Okay, and we used ones down here, even though we had counted up by twos. We still put the 1s, 3s, 5s, we still put those in there because we had a small enough amount that we could add those in there and still have enough space to draw our graph. So typically when you can, you want to add as much down here as you can because it makes it a lot easier to find the missing information inside of your graph. In this case, we have to go from 100 miles to 500 miles. Well, we obviously can't count by 1 because there's nowhere near 500 spaces here. Okay, but I know that I can count and see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I have 25 spaces. So I could take my 500 miles and divide it by 25. 25 goes into 50 twice. 25 goes into 0 once. So I could go up by 20s. But if I go up by 20s, I'm going to have a lot of weird spots in here. So since I know that it'd be 1 in 50, it's going to be a little bit difficult to plot those points in the middle. So what I could do is I could just use, okay, so instead of using it and getting it that small, because that's going to be a lot of different points, I could just count up by hundreds and I could skip a line again like I did down here. So for here it would be 100. Oh, and for the distance it was in miles. So you need your label and you need your units. Okay, so I have 100 and then I skip a line, 200, skip a line, 300, skip a line, 400, skip a line, 500. And we can keep going. Even though our table ends at 500, we can keep going. Okay, just to see what would be included. So now I know that my hours is my x and distance is my y because this is my x-axis. So it contains all my x coordinates. And this is my y-axis, so it contains all my y coordinates. So when we do ordered pairs, they are put together x comma y. So in this case, they're going to be put together as hours comma miles. So my first ordered pair is going to be 2, 100. And I want you to try to do these next 4. When you come back, we'll check your answer. All right, so you should have 4, 200, 6, 300, 8, 400, and 10, 500. So now what we do is we use the ordered pairs to plot points on the coordinate plane. So I look for 2, 100. So 2 is my x, so I go over to 2, and I go up to 100, and I plot my point. Then I know my next point is 4, 200. So I go over to 4, up to 200, and I plot my point. So on and so forth. So I want you to try to do these three on your own, and when you come back, we'll check your answer. All right, so you should have 6 and go up to 300, 7, and you should follow that up to 400. Okay, and always double check, make sure that you're going straight across and straight up and down. 8 hours will get you to 400. And oh my goodness, I said 7 gets you to 400. That's not the case. That's why you have to be careful and look at your numbers. 8 gets you to 400. And you know that 10 gets you to 500. Okay, and you know that if you travel 0 hours, you should go 0 miles. So we can put that point, we call that the origin, on our graph as well. And then now, typically what you'll do is you'll take a ruler and make a straight line that goes through all the dots. I'm going to use my straight line tool here. Okay, and it should hit all of your points. Now, mind you, I'm using a computer program, so it's not going to be as perfect, but it should still go through all of your points and make a straight line. Because since it's a constant change, you should have a straight line. Okay, so now what I can do is I can look and see, well, I want to know how much time, because I know that I'm going to be going 250 miles, and I want to know how much time that's going to take. So I use my graph and I find, well, where's 250 miles? Well, since I have this nice line in between, okay, so this line right here, since it's halfway between 0 and 100, I know that every middle line is worth another 50 units. So it would be 50, 100, 150, 200, and 250 is going to be right here. I'm going to use a red line there. So what I'm going to do is I'm going to follow that line all the way over until it hits my graph. This is where it hits my graph, so now I'm going to follow it down to figure out the amount of time it will take. Since the 250 hits the line and then drops down to 5, I know that they would have to wait 5 hours to get food. I can double check my answer using my equations, so I know that my number of hours, 5 times 50, should give me 250. Since this works, I know that my answer is correct. Okay, so what I want you to be able to do is I want you to be able to plot the points on the coordinate plane, and you need to be careful when you're making your intervals. So notice that we had a lot of extra space left over here. If we wanted to, we could have made our spaces even bigger and maybe skipped 2 or 3 lines in between. If you have enough space on your graph, what I would like you to try and do is I would like you to try and plot some of the other points that we had. So we had 612, and so 12 600, 14 700, and 16 800. Okay, I'd like you to try and plot those points on your graph so that way when you come to class we can check to see how you're doing with plotting points. As always, if you have any questions, please make sure to write them down so that way we can go over them in class. Okay. Also, make sure that you're trying to plot those points, but know that there are no other exercises that you have to do for class in a couple of days.